Hello, guys, welcome back to the wonderful channel. And let me take our time to appreciate everyone that has been taking our time to watch the series we have on board and subscribing as well. I really appreciate you. For today, we'll be introducing a new series, and this time around, it will be going back to the basic of computer programming and coding. So, it is a series with title Programming Logics and Techniques. Programming Logics and Techniques. Yeah, I've always wanted to do this series for those that have little or no programming background because it is aimed at helping you understand the nitty gritty in programming and um, um, making you understand the terminologies we use per time within this atmosphere. All right, let's go straight into business. Introduction. What is PLT? What is programming logic and technique? So we'll start by defining programming logic. What is programming logic? As we can see, it is the foundational framework that dictates how a computer performs particular tasks and solves problems. And while the programming technique itself is a structured method and practices that we developers use to write clean, efficient, and reliable code. So you can say the programming logic and technique is a combination of the foundational framework that dictates how the computer performs an operation in conjunction or in collaboration with the structure, method, and practices that we developers, you and I, will use to write clean and efficient code to produce a software program. Alright, so what will you be learning in PLT? What are we going to be discussing? We'll be discussing algorithm, flowcharts, pseudocode, decision making variables, basic data types, loops, arrays, operators, sorting, and of course, how to apply all of these things. So, yeah, it's gonna be a long ride. Maybe not so long, pretty short, but I mean, for those that are coming from a non-techie background, it will look or sound kind of long. All right, let's delve into the main thing. What is algorithm? We've seen algorithm, we've heard algorithm once or twice. What exactly is algorithm? Algorithm is a method of representing the step-by-step logical procedure for solving problem. So let's say algorithm is telling in a layman word, how do you intend to solve this problem? Explaining to the barest minimum non-techie person how you intend to solve a technical problem. That is what algorithm is. Algorithm is a lot like actual code, but it is not actual code. So you're going to be telling a layman in English, however, you're going to be writing something that looks like code, but it is not code. It is also independent of programming language. So algorithm does not mean you must understand PHP or Java or C++ or JavaScript, whatever it is. No. Algorithm that works for JavaScript would work exactly the same way for Java and PHP and C++ and React, whatever it is you have. Now, what are the components of algorithm? For the components of algorithm, we're looking at five major components, which is the input definition. You must define how your algorithm is taking input. In the same way, you must define how your algorithm will be outputting data. And then also, your algorithm must be accurate and precise. It must be effective, basically. And then it must be definiteness. It must have a defined order. The definiteness means there is a start, a continue, and the steps that the algorithm has to take has to be defined and well stipulated. And then finally, it must be finite. Finite means it's must not run continuously. I mean, you don't want to crash your computer, you don't want to crash your device, right? So it must have an end. Yeah, these are the components of an algorithm, and if an algorithm lacks one of these components, then the algorithm is not a perfect algorithm. All right, let's see something else that we have in conjunction to algorithm, right? Flowcharts. A flowchart is a type of diagram that represents a workflow or process. It is a diagrammatic representation of the solution or an algorithm to a given problem. So when you present your algorithm in a diagram format, it is seen as flowcharts. Now let's see what are the components of flowcharts. You don't just draw flowcharts because you've heard the name flowchart, right? You must follow some schematics and defined components to get a perfect flowchart. So when you see the oval shape, it represents the starting of a process. When you see a rectangle shape, it connotes that the process or operator step. So you're saying, okay, this is what is operating, is an operation step within your flowchart. And then the arrow, of course, indicates the flows between steps. And then diamond signifies a decision making, yes or no. Then the parallelogram is used for inputs and outputs. Remember, I said algorithm has must have an input and output. Also, the algorithm must have and a start, a finiteness. The finiteness is the oval, all right, and then the flow, the process, accuracy and precision talks about the operations of um, your algorithm. All right. Now let's see what an algorithm, a flowchart algorithm looks like. Yep. So it started from here. You read something, so you are taking an input, and you take another input, and then you calculate, which is the rectangle, right? When you calculate it, you also print it. Of course, it's still an operation, and finally it ends. So your algorithm started from here and it ended here. All right, for now, this is all we have. In our next series, we'll continue from the ending of this flowchart. Thank you very much and have a nice day. Please don't fail to subscribe and recommend to your friends. Ciao.